Delta math topic, determine if number is rational or irrational. Okay, this is actually pretty easy, okay? Because basically every number you ever deal with in math class, is going to be a rational number, except for those that have two kind of like, not red flags, but two things involved in them. Now, I'm talking 8th grade level math. I'm not getting higher and philosophical and talking all sorts of weird stuff, because you can get lots of different like perfect roots of different kinds of problems. But for our intents and purposes, we've got pi. Anything with pi on it is going to be irrational. Anything with a non-perfect square is going to be irrational. Okay. And what I like about perfect squares is we've been doing them a lot. Like you should be getting more and more familiar with them by now. So if you need to make a little cheat sheet, you can. So like 1 times 1 is 1. So the square root of 1 is 1. 2 times 2 is 4. So the square root of 4 is 2. 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. Okay. And I'll just go up to 100. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are just different names for those numbers. Okay. These are all perfect squares and they're all rational. Okay. Irrational numbers go on forever with no pattern. They're like that crazy old aunt who talks to you on the phone. She doesn't make any sense and she just doesn't stop. She goes on forever with no pattern. Doesn't make any sense. So anything in between these is going to be irrational. These are nice and neat, pretty little packaging, nice perfect squares, love it, but they're not irrational. Irrational are all the ones in between. Like I could say the square root of 37, or I could say the square root of 11, or I could say the square root of 83. Okay, anything that's between those perfect square roots. Okay, now again, there are other roots and there are other kind of irrational numbers out there, but these are the ones that you need to know. So if it's not a perfect square root, and if it has anything to do with pi, one more caveat, if you have something like, I don't know, like you have the perfect little 65, the square root of 65 or the square root of 65. Okay, you can simplify that first. Anything divided by itself is 1, and so that would simplify. If I had like 3 pi over 3 pi, that's also 1. Like, I don't know. Yeah, so those are basically irrational numbers, except for some of those maybe sneakier examples. But right off the bat, I can say, hey, the square root of 23, is that a perfect square root? Nope, it's not. So that's going to be irrational. It will go on forever and ever with no pattern. If you plug that into a calculator, it'll stop, only because your calculator stops. Otherwise, that number would like literally go on theoretically forever. Theoretically forever. Okay, so you want to have to go ahead. You want to pick whether it is or is not irrational, but then they give you reasons. Okay, so you want to make sure that you follow the reason. And so on this particular problem, it is irrational because it is the square root of a non-perfect square. And that's it. That's all you have to do. So it's a lot of explanation. It's pretty quick to do these problems. On this one, it's a little bit more involved, but they say, okay, here's this problem. And you're like, oh, it's got a pattern. You're like, oh, 0.68, 688, 688, 68888. I just keep adding 8 every time. Sorry, guys. This is not a pattern like that we are talking about. It's got to be a precise copy. If it's like 0.819, that'll work, but not like this evolving pattern. Okay, so this one is going to be irrational because it's going on and on forever. That's what the dots are. And then it looks like a pattern. Ooh, so they try to sneak that in there. They are sneaky. Okay, it's a decimal. It does not repeat. It doesn't terminate. Terminate means stop. It goes on forever, but there's no pattern. Okay, and that's it. Good luck. Goodbye.